Welcome students. Today we see about the IR spectroscopy. This is one of the absorption type or molecular vibration spectroscopy. The introductions about IR spectroscopy. IR spectroscopy is the study of absorption of IR radiation which result in vibrational transition. It is mainly used in structural elucidation to determine the functional group. This is the main uses of the IR spectroscopy. IR spectroscopy. This is the main uses of the IR spectroscopy. IR region present between the visible and microwave region in emitted radiation spectrum. In this IR EM spectrum is divided into three types. One is near IR, second one is middle IR, third one far IR. In near IR, wave number is 1400 to 4000 to 4000 centimeter. Wavelength of near IR is 0.8 to 2.5 micrometer. In second one is middle IR. In middle IR, wave number is 4000 to 400 centimeter. The wavelength of middle IR is 2.5 to 25 micrometer. Third one, far IR. IR means infrared radiation. Okay. In far IR, wave number is 400 to 10 centimeter and wavelength is 25 to 1000 micrometer. These are the IR of EM spectrum division. Next we see the principle. In principle means it is based on the absorption type or molecular vibration spectroscopy. IR spectroscopy is an important analytical technique used for the determining of functional group in certain compounds. The study of interaction of electromagnetic radiation with vibrational rotational reference within a molecular structure is termed as IR spectroscopy. When IR frequency is equal to the natural frequency of vibration, absorption of IR radiation takes place, a peak is observed. IR spectrum of the chemical substance is a fingerprint of molecule for its identification. This is known about the principles of IR spectroscopy. Next we see the modes of molecular vibration. The molecular vibration, the vibrations are divided into two types. One is stretching vibration, second one is blending vibration. The stretching vibration is again divided into symmetrical stretching vibration and second one is asymmetrical stretching vibration. And the second one type of molecular vibration is bending vibration, and the bending vibration is again divided into two, in-plane vibration and out-plane vibration. In-plane vibration is divided into scissoring vibration, rocking vibration. The out-plane vibration again divided into two, wagging vibration and twisting vibration. This is the classifications and or modes of molecular vibration. Next we see the one of one. First one type of vibration is stretching vibration. In stretching vibration means a stretching vibration again divided into symmetrical and asymmetrical. The stretching vibration means there are two atom bonds length. That one bond atom length, the two atoms bond lengths are increase or decrease symmetrically or uniformly. That is called stretching vibration. In stretching vibration divided into two types. Symmetrical stretching means in symmetrical stretching the two atoms bond length is increases or decreases symmetrically. This is called the symmetrical stretching. Second type, asymmetrical stretching means the one atom bond length is increases and another bond length is decreases. One atom bond decreases means another atom bond is increases. This is called the asymmetrical stretching. Second type of the vibration is bending vibration. Bending vibration is related to bond angle. It is divided into two types, in-plane bending and out-plane bending. In-plane bending means changes of bond angle take place inner molecule of which is axial symmetrical. The bond angle is changed in inner molecular. That is called bending vibration. In-plane vibration. In-plane vibration is again classified into two, scissoring and rocking. First one, scissoring. Scissoring means there is a change in bond angle whether it is increase or decrease in a plane. Only one time increase or decrease in the bond angle, that is called scissoring. Second one, rocking. Rocking means in this type of bending vibration take place in a plane of molecules. One atom bond angle in one direction moves in opposite direction. That will be a direction will be moves one direction to another direction. This is called rocking vibration. The bending vibration two types. First one in-plane we see. Second one out-plane vibration. Out-plane vibration means in this type of bending vibration take place outside the plane of the molecule. Outside the plane of the molecule, that one inside inner molecule. In-plane, out-plane means outside the plane takes the vibration bending. The out-plane bending is again classified into two, wagging and twisting. First one, wagging. Wagging means this type of vibration take place outside the plane of molecule in which two atoms bond angle moves in same direction. Two atoms bond angle. This vibration take place in the outside, but the two atom bonds moves in same direction means is called wagging vibration. Second one, twisting means one atom bond angle moves outside and another atom bond angle moves inside the plane. That is called twisting vibration. These are the types of the vibration and its classifications. Next we see about the instrumentation of the infrared radiation spectroscopy. There are two basic type of infrared spectrophotometer. First one is dispersive instrument, second one is Fourier transform IR instrument. In first one, dispersive instrument means in this the infrared light is separated into individual frequencies by dispersion using a grating monochromator. This light is separated individual frequencies, and this type of dispersive instrument we use the grating monochromator is used. That is called dispersive instrument. Second one, Fourier transform IR instrument. In this infrared frequencies are allowed to interact to produce an interference pattern, and this pattern is then analyzed mathematically using Fourier transforms to determine the individual frequencies and their intensities. This is called the Fourier transform IR instrument. This is the main instruments used in the infrared radiation. This is a picture of the dispersive spectrophotometer. This is one of the single beam spectrophotometer. In this dispersive spectrophotometer consists of source, entrance slit, dispersive device, assist slit. These all parts included in monochromator. Next have the sample and detector. Second, this one of the picture is Fourier transform IR spectrophotometer. In this spectrophotometer consists of congruent light source, beam splitter, recombinant beam, sample detector, stationary mirror, split beam, delayed split beam, moving mirror. This is the parts of Fourier transform IR spectrophotometer. This is the instrumentation of the IR spectrometer. Consists source, sample, monochromator, detector, readout value. In source, what are the source we used in infrared radiation spectrophotometer means Janus Cloyer, Glober, incandescence wire source, mercury arc lamp. Monochromators, what are the monochromator we used in IR spectrophotometer means prisms or gratings are mostly used. As detector, what are the detector we used in IR spectrophotometer means thermocouple, thermomobile, thermistor, bolometer, pyroelectric These are the detectors we used in the IR spectrophotometer. Next, readout it measured in recorder in graph in computer system. First instrumentation is source. We use many types source, Janus, Globar, incandescence, mercury atom. This is seen one by one. First source is Janus Globar. It is combinations of oxides of zirconium, erbium, usually of diameter 2 mm and length is 30 mm. It is in non-conducting at room temperature. So heating is required to bring conducting state. In this source, heating we use. Second one, globular source. It is made up of silicon carbide rod, usually diameter 4 mm and length 50 mm. This source is made up of silicon carbide rod. This source also we need the heating. Heating is required because to produce the IR radiation. Power consumption is normally higher than Janus Gloyer. Water cooling system needed because to cool the metallic rod, electrodes attached to the rod. Third one source of the IR radiation means incandescent lamp, a light wound nichrome coil heated to about 1100 degrees Celsius by electric current. A black film oxide is formed on coil give acceptable emissivity. It has longer life than Janus and globular source. It is very longest life than Janus source and globular source. Fourth source is mercury arc lamp used for FIR IR region. It is high pressure mercury arc. It is one of the high pressure mercury arc which consists of quartz jacketed tube containing mercury vapor at P at 1 atm. When current passes through the lamp, mercury is vaporized, excited and ionized, forming a plasma discharge at high pressure. This is the procedure for using the mercury arc lamp in IR spectroscopy. These are the sources we use in IR spectroscopy. Second one, sample handling. IR spectrometry deals with the measurement of IR spectrum. We measure the IR spectrum in IR spectroscopy. It is used for characterization of solid, liquid, gaseous samples. Material containing sample must be transparent to the IR radiation. Hence the salt, like what are the salts we used in sample handling in IR radiation means NaCl, sodium chloride, potassium bromide are only used in IR spectrometry sample handling. The sampling handling divided into three: sampling of solid, sampling of liquid, sampling of gases. First we see the sampling of solid is three technique we use: solid film technique, pressed pellet technique, mull technique. These are the technique we used in sampling of solid in sample handling. In solid film technique means the solid films can deposited on the surface of the potassium bromide or sodium chloride plates by allowing a solution in a volatile solvent to evaporate drop by drop on the surface of the flat. IR radiation is then passed through the thin layer depositor. This is known as the solid film techniques. Second one, pressed pellet technique. It is also known as the pressed pellet technique is also known as potassium bromide pellet method, which means in this technique a small amount of finely ground solid sample is mixed with 0.1 to 2% weight of dried powdered potassium bromide or NaCl and compressed. The mixture is compressed under very high pressure to yield the transparent disc about 1 cm in diameter and 1 to 2 mm thick. The disc is prepared in vacuum to eliminate air or moisture. These pellets are transparent to IR radiation and is used for analysis. This is the pressed pellet technique we use in sample handling of IR spectroscopy. This is the picture of pressed pellet technique or potassium bromide technique. Third technique of sample handling on solid mean or Mull's technique. In this technique, the finely crushed sample is mixed with mineral oil like Nujal in a mortar with a pestle to make a thick paste. The thin film is applied on the salt plate. This is mounted in the path of IR beam and spectrum is recorded. But these regions can be studied by preparing a mull with a complementary agent containing no CH bonds. Example, hexachlorobutadiene and chlorofluorocarbon soils are used. These are the technique we use in the sampling of solid in sampling technique of IR spectroscopy. Second sampling handling is sampling of liquid. First we see the first one see the solid sampling. Second one sampling of liquids. Liquids are usually examined as a thin film sandwich between two polished salt plates. Example NaCl we use in the sampling of liquids. Aqueous solvents cannot be used. They only use the organic solvents like chloroform only used. Sample thickness should be 0.01 to 0.1 millimeter to give transmittance between 15% and 70%. Some salt plates are highly soluble in water, so sample and washing reagents must be anhydrous. For example, what are the salts we used in it? Toluene and chloroform is solvents are used in sampling of liquids. This is the pictures about the sampling of liquids. Third one, sample handling. Sampling of gases. Sampling of gases can be obtained by permitting the sample to expand into the evacuated cylindrical cell equipped with IR transparent windows. The gases must not react with the cell windows. Gas analysis are performed with IR, but the method is not commonly used because lack of sensitivity is acquired. Moisture must be avoided in the sampling of gas. The windows and other instruments components which are constructed of soluble salts may be damaged. These are the sampling techniques we used in the IR spectroscopy. Third parts of the IR spectroscopy instrumentation is monochromators. Monochromator means we change a light, polychromatic light into monochromatic light. That is called the monochromator. What are the monochromators we used in the IR spectrometer means prisms and gratings are used. To select radiations of the desired frequency from source and eliminate other frequencies is a consist of monochromator, which consists of dispersion element and slit systems. In this monochromator we can assist and entrance slit, and we have the prism. These all are called the monochromators. This is a prism monochromator. This is a picture single pass monochromator. This is a double pass monochromator. This is the grating monochromator. We use the grating in the IR spectroscopy. This is the in down picture grating. Parallel grooves are present in the IR spectrophotometer that we use. That is called the grating monochromator. Then fourth one, detectors. We use all the instrument in IR spectroscopy. Also we need the instrument. Detectors are used. First detector is thermocouple. Thermocouple detector is based upon the fact that when two different semiconductor metal wires of high thermoelectric efficiency are conducted and kept at different temperature, the potential difference is developed between them, which causes the flow of current. The response time 60 minutes per second. Thermocouple is closed in an evacuated steel casing with potassium bromide binder to avoid the losses of energy by convection. This is working of the thermocouple is when the radiation falls on the hot junction is conducted the heat to cold junction. It causes potential difference between two junctions, and the changes of potential difference which is measured by using galvanometer. We use the measurement. This is the working process of the thermocouple. Thermocouple consists cold junction, hot junction, light barriers, bismuth, infrared radiation and galvanometer are present in the thermocouple. Second one, thermomobile. Thermomobile. Thermomobiles means to enhance sensitivity. Several thermocouples contracted in this series to give better results. Thermocouple consists of hot junction, cold junction, infrared radiation, light barriers also present. Third detectors bolometer. Bolometer main principle is Wheatstone bridge principle. For every 1 degree Celsius rises in temperature, electric resistance of metal increases. The bolometer usually consists of thin metal conductor made up of platinum strips coated with lamp black. The amount of current flowing through galvanometer measure the intensity of radiation falling on the detector. These are be detected by the bolometer detector. The response time 4 minutes per second we need in this detector. Bolometer structure consists of resistance, current passing, responsive element, aluminum or bismuth we use, and ammeter also present. Bolometer construction, it consists the responsive metal elements like aluminum and bismuth elements are present in the bolometer. It acts as the semiconductor which is connected through electrical circuit and positive reflection is measured using the galvanometer. This is known about the bolometer of the detectors. The fourth one, pyroelectric detector. It consists of thin plate of pyroelectric crystal of 0.25 to 12 mm in size. The crystal is placed between two electrodes and which is connected to an external electric circuit. When the crystal is exposed to IR radiation, it absorbs the heat leading to changes in its dipole moment. In the various pyroelectric crystals are barium, titanium and lead. Response time for pyroelectric detector is 10 minutes per second. Pyroelectric detector parts are pyroelectric element, electrode and resistance. They are present in two electrodes. One is cathode and anode and lead be present in the pyroelectric detectors. Working of pyroelectric detector. When a higher radiation which is falls on the pyroelectric material causes polarization of molecules, moves on the single direction are aligned, which causes potential difference between two electrodes. The potential difference is measured by galvanometer. All the detectors, the potential difference is measured by the galvanometer only. This is the working condition of the pyroelectric detectors. Next we see the factors affecting vibrational frequencies. First one of the factors affecting vibrational coupling also affect the vibrational frequencies. Second one, hydrogen bonding. The bonding between hydrogen that also affect the vibrational frequencies. Third one, electronic effect. Electronic effect also affect the vibrational frequencies. Bond angle and resonance also affect vibrational frequencies. These are the factors affecting vibrational frequencies. In vibrational coupling, an isolated CH bond has only one stretching vibrational frequencies, whereas methylene group shows two stretching vibration, symmetrical and asymmetrical. Because of coupling, interaction between CH stretching vibration in the CH2 group. Asymmetric vibration occurs at higher frequency than symmetric stretching vibration. This is known as vibration coupling because these vibrations cause at different frequencies than record for an isolated CH stretching. Second one of the factors affecting hydrogen bonding. In hydrogen bonding, OH and NH compounds give rise to number of effects in infrared spectra, while most organic work will involve relatively non-associating solvents like CCl4, அப்புறம் வந்து CHCl3 or more polar solvents such as acetone benzene will certainly influence OH and NH absorption. So affect the hydrogen bonding, also affecting the vibrational frequencies. Third one, electronic effects. Changes in the absorption frequencies for a particular group take place when the substituents in its neighborhood of that particular group are changed. It includes inductive effect, mesomeric effect, field effect. Fourth, this also affect the vibration frequencies. Fourth one, bond angle. Cyclopropanes have high CH structure frequencies. For the same reason, the C bond bond angle is substantially contracted below the normal 109.5 degree, leading to increase S character in the CH bonds and thus to higher frequencies. The fifth one, resonance. Because of resonance, carboxylic acid shows more absorption compared to alcohol. So, resonance also affect the factors affecting the vibrational frequencies. In this way, resonance can affect the absorption of IR and CO structure. After the detector, we detect the vibration and the readout value is measured by computer analysis, and readout value is occurring graph method. This is the instrumental methods of infrared radiation. Another we see the applications of the infrared radiation spectrophotometer. First application is determination of molecular structure. One certain common to determine the molecular structure we use IR spectrophotometer. It is the main applications of IR spectrophotometer, and we to determine the functional groups. We determine functional group of the certain compound. Second one, studying the progress of the reaction. To study the reaction progress of the certain compound in IR spectrophotometer. Third one, qualitative analysis of functional group, to determine the functional group, and quality, to identify functional group quality. The fourth application is detection of impurity in a compound. To detect the impurity of a certain compound is the best method for determination of impurities in organic molecules. And the fifth one is the shape of symmetry of the molecule, to determine what the type of symmetry shape that molecule, that will be identified by IR spectrophotometer. Sixth application is presence of water in a sample. To identify sample, to identify the presence of water in a sample, that will be identified by infrared spectrophotometer. Next one, seventh type, to examinations of old paintings and artifacts. To exam old paints, அதை வந்து examination பண்ணலாம். And artifacts. Eighth, identification of organic. New organic compound was identified, and molecular form structure will identify, determine, and the functional group also identify. These are the application of the infrared radiation spectrophotometer. Next we recollect the infrared radiation spectrophotometer. This day we see the infrared radiation spectrophotometer. First we see the introduction. Introduction of the IR spectroscopy. Defines IR spectroscopy means to determine the functional group. It is also known as molecular vibration spectroscopy or absorption spectroscopy. Three region near middle for, and next we see the principle. Principle is based on the absorption spectroscopy. It identify by using the vibration by the molecules, functional group, etc. And we see the vibration and the types classification. We see stretching, bending. Stretching divided to symmetrical and asymmetrical. Second type bending, in-plane, out-plane. In-plane is again divided to scissoring, rocking. Out-plane vibration divided to wagging and twisting. Next we see the instrumentation of the infrared spectrophotometer. Two type dispersive system for a transform IR instruments. This is a picture of the dispersive spectrophotometer, and for a transform IR spectrophotometer, this is the picture and the instrumentation process. Source, sample, monochromator, detector, readout. What are the source we use in IR spectrophoto means Janus Cloyer, Globier, incandescence wire source, mercury arc lamp. What are the monochromator we use IR spectrophotometer means prism and grating. What are the detector we use means thermocouple, thermomobiles, thermistor, bolometer, pyroelectric. Readout recorder in a graph. Sources, Janust. Sources, sample handling. Sample handling divided into three: sampling of solid, sampling of liquid, sampling of acid. These also see in this class. What are the technique we used in the solid sampling? That also we see. Solid film technique, press pellet technique, mist technique. Technique. Sampling of liquids and sampling of gases also we today discuss. Next, monochromator, two types, prism, grating. This is the structure of prism, monochromator, double pass. This one single pass monochromator, double pass monochromator, grafting monochromator. We use the grafting. Detectors, next we see the detectors: thermocouple detector, thermomobile, bolometer, and pyroelectric detector. These detectors are discussed. And next we see the factors affecting vibrational frequencies. First one, vibrational coupling, hydrogen bonding, electronic effects, bond angle, resonance. These also see explain. And next we see the application. Once again revise the application of the IR infrared radiation spectrophotometer. First one, the determinations of this molecular structure. Second one, studying the progress of the reaction. Third one, qualitative analysis of functional group. Fourth one, detection of impurity as in a compound, shape of symmetry of the molecule, presence of water in a sample, examinations of old paintings and artifacts, identifications of organic compounds. These are the application of the infrared spectrophotometer. Another one topic we see the IR spectrophotometer is finished, but in one topic, the quenching, the fluorimetry in quenching process also we see. Quenching, the fluorescent densities can be decreased by various factors: changing of solvent, change of wavelength, temperature, pressure, viscosity of the solution, rigidity of the structure, concentration of solid molecules. The types of quenching: self-quenching, chemical quenching, collisional quenching, and statical quenching. These are the four types of quenching. First one, self-quenching. The drug substance itself, it is act as acid or base or catalyst produce quenching. Second type, chemical quenching. If any added intermediate or chemical substance produce quenching effect, is also known as chemical quenching. In chemical quenching, if any added intermediate or chemical substance produce quenching. In self-quenching means the drug substance itself acts as quenching effect. That is called self-quenching and chemical quenching. Third type, collisional quenching. Due to increasing the temperature or pressure, the collision between the molecules, it more produce quenching. in the temperature are increase in some times. That time they produce the quenching effect more. That is called the collisional quenching. The fourth types of quenching is statistical quenching. This type of quenching is due to regularly increases concentration of drug substance in a systematic analysis. The regulatory increase concentration, drug substance concentration is increases. That time produce the statistic quenching. These are the types of the quenching and the quenching types.